What's going on, everybody? So, I've been studying several things lately. Several different types of SQL, regular expressions, some stuff about Viking history with leatherwork. Looking at actually trying to maybe start doing things with Python because Python is Python. And I wanted to test out the Kite AI stuff with Python. And I have submitted my runes package to CRAN. Still waiting for the approval for that. But so there's stuff going on with R development, and I might be looking at Python stuff. But really useful with Linux, the command line, sed, and any sort of text stream, text manipulation are regular expressions. They come in handy a lot when it comes to doing anything on the Linux or Unix command line, and with sed or grep or anything like that when it's looking at or dealing with text. And with Linux and Unix, everything's a file, everything is text, so regular expressions become all the more powerful. I've been reading a book I got from like a Humble Bundle thing. I got like 15 books on like Linux, the command line, the utilities, Vim, Emacs, whatever. And some of it is, very familiar. I've just kind of figured out a few things that just worked because I needed them for whatever reason or not. So I already knew a few things. But I've been learning a lot from this, and just like as a brief overview, this specific book is like 150 pages, and I have another one that's like 500 pages. I'm like skimming through, grabbing the most useful bits. Things like, depending on which type of substitutions that you can do, we have like the escape D is basically the same as doing a bracket 0 to 9, or listing out 0, 1, 2, 3, 4, all the way to 9. Inside the brackets, that means anything that is contained in here, any instance of that. So this could be, when it says 0 to 9, it's saying if you find a 0, yes. If you find a 1, yes. All the way to 9, just any of them, anything in the brackets. This does not work for words because this breaks down each item in the bracket. And so if you typed in the word hello, it would be looking for H's, E's, L's, and O's. So anything in here is like a single unit or a single item. So this would look for A, B, or C, not ABC. But with D, digit stands for 0 to 9. So if you're just looking for a number, then you could just do digit. And if you're looking for a telephone number that starts with 3 numbers, you could do digit with the quantifier, which is the brackets and the number. So this would say I want 8 of whatever is to my left, this. So 8 digits, or in this case, 3. So you could easily do that for shorthand instead of doing something like this, or 3 of these, where it's 0 to 9, 2 more brackets, 0 to 9, 2 more brackets, 0 to 9. It's more shorthand, and it makes your regular expressions a little shorter, easier to read and understand, and still just as powerful. Capital D will match any non-digit characters. So this would be like your anything other than numbers. Anything other than numbers. Now, toggle this over. Yeah. And then inside the square brackets, if you use a caret symbol, this is basically a negation. So it's saying do the opposite. So if you have caret 0 to 9, that's saying anything other than 0 to 9, or not 0 to 9. I am looking for not 0 to 9 in this, whatever this is looking for. And the same thing goes for caret D, because D is digit 0 to 9. So these negations work on the shorthand as well. W would be like for matching words without white space, because capital D will match white space, punctuations, hyphen, everything other than digits. And W does not. W matches only letters and numbers. So basically what you see in here, all lowercase alpha, uppercase alpha, and numeric. Now, capital W does the opposite. It has basically just the aforementioned pattern with a negation. So it's saying anything that is alpha, upper alpha, or numeric, I don't want those. So give me not those things. S would match a space. The N and T, I'm sure you guys are all very familiar with this one. This is kind of standard, new line and tab. And then R is a carriage return or enter. So it's a little bit different from new line. That would be like if you just hit enter. A period matches a single character, so it could be any character. It's like a wild card, but for a single character. We covered quantifier, so in this case, if you want to do like an 8-character word, you could just do period with an 8 quantifier like this, and that would match 8 characters, or 8 anything. B is boundary. I've never actually used this one, and I'm not quite sure too much about this, because I would typically just use the anchors, which is the caret and the $sign. The $sign I remember because in Vim, the end of a line you go to with a $sign, so that one's easy, but caret is the beginning of a line. And depending on whatever regex processor you're using or whatever it's going on, the caret could be a beginning of a line, the beginning of a document. It could be any number of things. But this is just like what I'm doing right now is I'm building out a like cheat sheet list of regex stuff for future reference. And I found this really cool, thanks to this book, this really cool link, regexpal.com. And going in here, you could type in, say, like a number. So let's just say we got like a phone number, and I want to match digits /D. Oh, there's all my digits. But if I wanted to do digits with a quantifier, oh, there's all matches for that. So if I did this, and then I could do D, and then another quantifier of 3, and then I wanted another dash, and then another quantifier, but for 4. And this could match a phone number. 3 digits, dash, 3 more digits, dash, and then 4 digits. Now, if you're going to do more complex types of pattern matching, like what if you want to have optional parentheses around the first part of the phone number, or if you want to have that international number, like for US, it's 1 dash and then your 334 numbers. That's when you start getting into more and more complicated types of regex. And the regex pattern matching for emails is intimidating to look at. Regex can be really, really useful, especially when you're doing like small little one-off things, finding pieces of text, using grep and sed. Really, really great and powerful. But the syntax is just like bash. It's horrendous for legibility. And it takes some time to dissect and understand what exactly is going on. And it's very piecemeal. But at least understanding some of the basics would very much help you out with command line stuff. Because if I was going to go to, let's make a directory, make dir test, cd test. All right, so I have nothing in this directory. What if I wanted to make 10 directories? So let's do that. Let's say make 10 directories. I want to make dir, and let's name them all, sub test, but I want to make 10 of them, and I want to name them. So let's say I want to name them with a number, and I want to number them 1 to 10. Now in regex, the quantifier in the braces tells you how many of something to do. But we can also give it a range, and with this command, I'm not sure if this actually counts as regex or not. This is just something I do because I found it interesting. Braces, I could do 1, and in bash, it's ... You could do 10, brace again, and boom. And then if I list out, I have those 10 subdirectories. And so you could easily do stuff like that. So this type of regex stuff, like I'm not really sure if this is really the perfect use for it. Let me go. I have a file to do. So I have a file called to do. I got stuff in there. So let's do grep on that. So I want to do grep, and I want to find out all of the. I did this video before where I did all of the outline of a markdown document by using regex to pull out all of the hash symbols. So we could do grep, and I need to escape the hash, and I'm going to pull that out of to do. And I get the structure, which is these are like my Kanban board stuff for Taskle, these icebox, etc. This is like the structure. So what if I only wanted to match a single hash symbol? So in that case, I could do grep, and then I could do a single hash symbol, but starting at the beginning of a line and then an end of a line because the $symbol. So this is basically, I'm escaping the hash symbol because it's a protected character, but the caret and the $ say the beginning of the line begins with a hash symbol and then it ends the line. Or in this case, I could just do a space. because I would want a space after it, in which case I probably need to escape that as well. I'm not sure if I need to escape the caret, but I'm not going to find anything in there because I don't have any single hash symbols. But if I did 2, it would still pull up all of those. So yeah, with grep and sed is basically just like simplified regular expressions, because if I did, let's see, cat do, I don't know. I don't know what I want to replace. But yeah, so let's just try sed replace. Let's do the double hash. Oops, double hash. And let's do that with hello and global. And I'm going to do that on the to-do file. And so if I went way up here, define, this is all my completed tasks right here. So you can see like right here, I got hello, hello, hello. So sed is just a stream editor. That doesn't actually change my file, but it's basically using regex in a way, but with a specific sed syntax. But yes, regular expressions are a beast to like really study and get into. But I wanted to make like a somewhat of an effort to really like look at it and get some of the basics down pat, because they are very useful for text processing, and you can use them in R. Because with my runes package, I actually used regular expressions in a way to perform the functions that are in my runes package to find the text or each text character and replace them with the Unicode runes characters. So G sub here is kind of like grep in a way. It finds the pattern and it will replace it with something else. And in which case, you see I have the brackets here because some runes, some Elder Futhark runes, are covered for multiple characters. So V and W, C and K, J and Y, all are covered by the same rune. This would be Vunyo, Kenaz, and Yara. So each of these have a single rune that corresponds to 2 letters, but I want to find every instance of a single letter by itself. And in this case, these brackets are like the regular expressions. Anytime you see a W or a V, replace it with this Unicode character. And it does that for all of these. But also putting them in double quotes like this, because certain runes are a combination of 2 characters. A T by itself and an H by itself are 2 separate runes, but together they're the Thorisaz rune. So TH is its own combination as well, while I also have T here and H here. So using regular expressions in this way helped me with my text processing of English text to Elder Futhark runes in this package. So just another example of a use case for regex. Regex is ubiquitous. It is everywhere. It is really amazing for text processing, especially on the command line with sed, and you will use regex eventually if you're doing development. Some way, somehow, you will come across regex. I'm pretty 100% sure about that, or at least somewhat close. Anyways, regular expressions, they're cool. Check them out. They're intimidating, but learn some pieces. Play around with the pieces. Use some with sed. Use some with grep. Caret and the $sign for beginning and end of line. Some bracket stuff and what's in the brackets. That right there, you're going to get a lot done with just that, and then add some braces for the quantifiers. You're looking good at that point. So just start playing around with this stuff. See what you can use it with to make use of it. But yes, regular expressions. All right, have fun.